Washington Valley Economic Council. I want to welcome you all here. I think we have an exceptionally good program, and I'm glad as well that Valley Vision will be taping it so that we can share it with the rest of the Valley who haven't made it in today. First, I want to thank New Hampshire Electric Cooperative. They have been underwriting Eggs and Issues again this year. When I say again, this is at least the second, perhaps the third year. Jack, is it the third? The third year that they have been underwriting us, and we're very pleased because we do bring a variety of speakers to the North Country that ordinarily we would not have access to. I also want to thank Ron Sandstrom as our business sponsor. His check will pay for the Valley Vision, and it will be shown 6 times over the next month, and anyone who's interested can catch it there. So, without further ado, and I brought my cheat sheet because Dan's title is Regional Manager at Robotics Education and Competition Foundation, and I wanted to make sure I got that accurately. For those of us who read local papers, we've been following the fact that our Kennett students have been doing some very interesting things in robotics, so we thought it would be quite timely to talk about what's going on the larger scale. So, Dan.
There you go. Okay, today I'm going to talk a little bit about why robotics is important, and specifically why is it important to industry. A little bit about myself. I'm born and raised in New Hampshire, from Manchester, New Hampshire. I went to WPI. I'm a mechanical engineer. I got my MBA from UNH. I have an industrial background, designing CNC machines, robotics, and automation. My territories are, I'm responsible for all of the programs, all of the events in New England and New York, as well as all the teams. So it's a little big. And growing up in Manchester, doing robotics with FIRST, I've been doing robotics for over 20 years. So I have a passion for it, and yeah, that'll probably come out during the presentation. I really want to talk about like what a robot is, and some perceptions of what robotics is. Typically we get the perceptions from movies. So we can all relate to that. We all think that that's a robot. That's the image that's in your head. We got WALL-E. Kids love this stuff. Some of the older generation, some of the R2-D2 and C-3PO. And then going back a little further, Rosie. Rosie was the best robot ever. It cleaned, it cooked. It was that great thing that everybody wanted robotics to be. So every robot is essentially 3 things. It's some kind of mechanical system. It has some electronics that process information. And it has some kind of a feedback system so that it can take the information and make decisions about it. So one question, is that a robot? Well, let's think about it. It's a mechanical system. Some of the microwaves today talk to you, so they're very smart. And when you open the door, what does it do? It stops. So essentially, this is a robot. So just keep that in the back of your head, because people start pigeoning robotics into a very specific corner, and that's really not what it is. Today's society is very, very automated, and something as simple as your phone, in most cases, could be considered a robot. We typically use robots to help society to do the things that are dirty, dull, and dangerous. The things that we don't want to do, or just basically hurt humanity, and workman's comp issues in a lot of cases. When robotics really started breaking into industry, this is what robots looked like. They were all industrial arms, and they were used in manufacturing areas, typically like in assembly lines, where multiple robots would be working on a car on an automated line, and then some factories are kicking out a car every 30 seconds because the entire process to build the car is automated. I talked a little bit about the dangerous part. Now, would you imagine all of the welders that would have to be that close to do that many welds at that time, that cannot be done by humans. That has to be automated, and it's a lot safer, it's a lot more reliable, and it's a lot more consistent. A new thing that's coming out are service robots. You know, things that help you around the house. People are putting a lot of R&D dollars into these type of robots. This one is called Asimo. If you've never seen him, he's absolutely amazing. This robot stands about 4 feet tall, weighs about 180 pounds, can walk upstairs, has 2 vision cameras, sensors, has its own Wi-Fi. It can basically communicate, but it's an unbelievable. Check out the YouTube video for this because it's really amazing what it can do. Some of you guys have seen iRobot's Roomba. You know, this is another thing. Like, you know, I know you all love to vacuum. So this is one of those things. Is like they took vacuuming and they made it into an automated application. A lot of you know Dean Kamen down in Manchester with DECA. Dean designed a robotic arm that basically mounts onto the shoulder area and helps people, especially people that were in the military that might have lost an arm, you know, helps them try and, you know, get back some of the things that they were able to do before. And that's an amazing arm too. It has, it only weighs about 7 pounds, and it can pick up a water bottle and it can pick up a grape. It's very sensitive, and there's a lot of amazing technology that's in the development of that arm. There's lots of military applications, and again, these come into under the dangerous category. You know, this is a bomb detecting robot that can actually go out. It has a camera, has tank treads, so it can go into different areas. It has a microphone, so it can listen to an area. It has some weapons on it in case it needs it. But these are the type of things that you can send this into a very dangerous zone and protect human life. This is another version of this, but this is kind of a neat one where it can actually climb stairs. And because of its arm, it can actually reach into garbage cans, and it has a little bit more dexterity. This is a robot called Big Dog, and it was made down in by Boston Scientific down in Massachusetts. And this is a robot that basically walks like a dog, and it can carry about 400 pounds of equipment on top of it. And again, there's a really cool video with this. You know, if you kick the robot, it actually will stabilize itself and not fall down. So this thing can walk on ice. This thing can walk up hills. It's amazing technology, and you know, the R&D that goes into this in 5 to 10 years will translate into everyday society. So that's why a lot of people in industry are putting a lot of R&D dollars into robotics, because that same technology that might be used for a military application 5 or 10 years down the road are helping people walk or replacing legs or doing that kind of stuff. You know, a lot of theories on drones right now, and what's a drone and what's legal and what's not. This is, but again, just another application of robotics that can protect lives. Some of you in this room might have had surgery by the Da Vinci system. This system allows the surgeon to make incisions and operations that the human hand cannot do. It's very repeatable. The technician or the doctor has to be trained on the system. And it's almost really like that little booth to the left there. That's like a little virtual reality room. And they actually go and they manipulate the entire robot right there. But it's an amazing application of robotics. Now, I'm going to go into a little bit about what my foundation does. What is educational robotics? and why is it important to industry? The whole goal of our foundation is to basically increase STEM education and engage as many students as we can in our programs. And we do that with curriculum-based robotics programs, and we try and make it as sustainable and affordable as possible. Why robotics? Well, it's educational, it's competitive, you can do some instruction with it, it's a good teaching moment, it's at the core of STEM education, it's hands-on so the kids can really relate to it. While they're building the robot, the kids are collaborating on designs, and they're collaborating with other teams. And it's really starting to teach them life skills, how to deal with somebody you can't work with, how to be a leader, how to follow instruction. Basically, our STEM pipeline now reaches all the way down into the elementary school and goes all the way up to college. So we have the VEX IQ system for the elementary that kind of overlaps into the middle school. And then we have the VEX robotics system that goes from the middle school to the high school. And then in the post-secondary, we have a program called VEX U, and that is for colleges.
Dan, for the sake of our larger audience, could you define STEM?
Okay, science, technology, engineering, and math. That's a good point. That word gets thrown around a lot. Okay, and people just throw it around like it's another acronym. Having done robotics for 20 years, I've been doing STEM for 20 years before it was called STEM. But it's really kind of thinking outside the box and basically teaching in a whole nother way. Problem solving, open-ended design challenges, really trying to get things to cross between science, technology, engineering, and math. And then this all translates into the workforce. And so as we start building the skill set all the way from elementary to college, that translates directly into the workforce. Okay? And if they go through this entire program, if they go through any robotics program, they are amazing employees on the other end. If you are a business out there, I used to be the chief technology officer for Intelitech, and at any one time I would have 5 interns from the robotics team, and they were great because I could work with them. I knew what their capabilities were, and I could almost try them out before I ever even hired them, because I was working with them the entire time that we were doing I was mentoring them as a robotics on the robotics team, but I could tell where these kids were going and what they wanted to do. So it was a great opportunity to actually backfeed young talent into our organization. One of the very first kids that I mentored 18 years ago when I was running my own team is now the manufacturing manager at Intelitech. So we have a network of partners. We have a lot of curriculum partners. We deal with a lot of, obviously, schools and colleges. We deal a lot with the government. We try to involve as much industry and a lot of other extracurricular activities like after-school programs, Boy Scouts, Girls Club, Boys Club. We're really trying to involve a lot of people to spread the word about robotics and STEM education. That's really the foundation, the goal of our foundation. This past year, we've had incredible growth. We're now in over 25 countries. We have over 400 events worldwide, over 8,000 teams, and over 100,000 students that we serve. Now, by introducing the VEX IQ program this year, we expect those numbers to grow amazingly. This is a very interesting chart about robotics in general. And you can see that robotics, since 2005, when VEX was originally started, it has grown amazingly But notice what's the best part is every one of the programs, BOTBALL, BEST, FRC, FTC, VEX, this is a high school only chart right now, but every one of them are growing. So that's a great trend to see, and people are actually starting to get why robotics is so neat and so fun to do with the kids. Really kind of tricks them into learning.
You want to define VEX?
VEX is the name of a brand. Okay, so VEX Robotics System is, we'll get into that a little bit later, but it's a design system that kids can use to build robots. And we're actually going to do a demo later. So if you looked at that chart, you can start looking at all of the other programs. So you have FTC, you have FRC, you have BEST, and you have BOTBALL. And if you add them all together, essentially, that's actually less than all of the VEX teams in the world. So VEX is actually, the VEX robotics competition has been growing almost double for the past 3 years. And there's a lot of reasons for that. And I'll get into some of that in a minute. But again, we always come back to affordability and sustainability and accessibility. That's the biggest key to our success. And we just try and stay as close to that mission as possible. We do have the largest classroom-based robotics competition in the world. We hit, last year was over 7,300 teams. And we are developing a great pipeline from middle school to high school, and now this year from elementary all the way to college. We have a tiered competition schedule where the teams will compete at a local level, and then they'll go into a state championship or a regional championship. Then they'll move into a national. We have some other national championships like in Asia, the World Cup. We have a U.S. championship and one in Latin America. And everything funnels into our World Championship that's held in April. Now, the neat part about our World Championship is it's our culminating event. But it's also the launch of our new season. All of the VEX robotics competitions are a year-round program. And we do this because we have customers in China and in New Zealand, and they're playing the game right now. They've been playing this game, the VEX Robotics Challenge, for several months now. And they're just starting to have their championships now, where in the US, we're just starting to have competitions. Actually, our first competitions this weekend down in Manchester at Trinity High School. So it is really a year-round program that culminates in April and starts again in April. Another neat part about our foundation is that we do work with a lot of colleges and industrial partners, and they help us provide scholarships. It's a brand new program that we started last year. And this will, right now we currently have about $1 million in scholarships available to VEX students. And that number is just growing. Here are some of our foundation sponsors. EMC, NASA, Texas Instruments, Microchip, Northrop Grumman. These are the people that really allow our foundation to do all the grants and put on the events and travel and do cool presentations like this. We have some program partners. So I've been talking about the VEX robotics competition. Well, the VEX design systems also used in BEST, the BEST competition, TSA, as well as Skills USA. So the VEX brand actually in our foundation supports all of those programs. I am actually one of the national technical chairs for Skills USA Mobile Robotics. So if you have questions, ask. We also have a lot of classroom partners. Project Lead the Way has each one of these organizations has specific curriculum designed for in the classroom use. Project Lead the Way, Autodesk, Carnegie Mellon, and Intelitech. Our foundation really has 2 great online resources, and these are some things that I direct you to go check out. The first one is our roboticseducation.org, and this does team grants, scholarships, basically all the resources that we have for our event partners. They're all posted up there. Everything's free. Everything's just there so you have the information right at your fingertips. Our robot events is basically how we promote all of the other robotic competitions out there. So if you wanted to know when there was a best tournament, you could go to the website, you could actually click on the best icon, and it would give you all the dates for the best competition. The same thing with VRC or VEXIQ or VEXU. We also have some forums where all the kids can actually share ideas and basically communicate with each other. This is the site that we also do all of our registrations, and this is how we keep track of which team has registered, which teams are in which states or which countries. And if you want to know that, we actually have a map. If you click on the map button, it'll show you all the events or all the teams in your specific area of the world. This is the example of our educational website. And here's an example of our robot events site. You can see the different tiles right there that you can click on. There's first, bot-ball, best, VEXU. This has been updated. TSA. So any of those, you click on them, it'll actually talk to you about the program, and then it'll give you all the event listings. I mentioned a little earlier about tricking kids into learning. Well, way back in the day, people had this great idea. They had this problem. Kids didn't want to take their vitamins. So what did they do? Make gummy bears out of them and put them in cool shapes. They kind of masked it up, but the kids are still taking vitamins, okay? So that's really what robotics is to STEM education. We're tricking the kids into learning what industry needs today. They need programming. They need mechanical design, electrical design, troubleshooting, open-ended problem solving, leadership, and taking pride in a job well done. These are all goals that, as employers, you want your employees to have this skill set. There are no more jobs out there. The jobs are getting smaller and smaller in a manufacturing setting where you can only know how to push a button, or you can only know how to operate a drill press. Now you need to know how to program that drill press, or how to troubleshoot the mechanical mechanism on the drill press. Everything's automated. So the jobs that we had a long time ago are now becoming automated, and the skill set that the kids need to do those jobs when they get into the workforce, we have to start teaching them now, like in elementary school. You can't wait till they get older, because then they have dreams of other things. We talk about sports. Sports are a big part of all of our kids' lives. My kids are in sports. It's a great thing for them. But I know my kids aren't going to be professional athletes, okay? I know for a fact. They might surprise me, but I doubt it. But what I do know is they do have the potential and the opportunity to be the next best engineer, or the next best innovator, or the next best doctor. This is all about problem solving. We do problem solving every day. So they might not all be engineers when they leave the robotics competitions, but that's not what our purpose. Our purpose is to teach them how to think on their feet and to basically just stand on their own. What I'd like to do now is actually show you a couple of the kids that are in the program, and we're going to ask them some questions. So Kennett High School is one of the local VEX robotics teams in the area. They've done amazingly well at some of the competitions. Last year, they brought 2 teams out to the World Championship. So what I'd like them to do is, can I have a couple of the students come up and show your robot over here? So you guys can come introduce yourselves.
Hello, I'm Kathy. I'm also 2 other people today, but
Hello, I'm Tom. I have no clue what I'm supposed to say, but hello.
That's okay.
Robotics
Robotics rules. What I want you guys to do is grab your robot. You guys can turn it on. You bring it out here so the camera can see it. And then, Kathy, while he's turning that on, why don't you tell them a little bit about what the competition is this year and what this is trying to do?
The competition this year is to score big balls and little balls into troughs or areas so that you can score points. So doing this, you have to pick up these balls, which
It worked earlier this morning.
well,
So in their defense, the very first competition of the season is this weekend. So a lot of the robots are really just starting to wake up. The whole purpose of the design system the way it is, here in New Hampshire, we have probably 6 or 7 competitions that the kids will be able to go to this year. And they'll be able to practice their engineering design cycle over and over again. So we literally have them compete in October. They'll compete in November, December, January, February, March. And in March, they'll actually have their state or regional championship down in Worcester, Mass. They have to qualify into that championship, and then those winners will actually go on to the World Championship. Now, if you haven't seen VEX Robotics before, this is the middle school, high school program, and it's really an erector set on steroids. It has a brain. The system's designed for up to 10 motors. They have all sorts of sensors. And the best part about the system is, in order to build it, you need a hacksaw and a file. Okay? There's no machining, there's no nothing. So what it really does is let the kids be very creative on their own. They don't need an engineer telling them what to do or designing the robot for them. They can really start exploring whatever's in their head and really try and make those ideas, what's in their head, come alive into a physical thing that they can mechanically build, electrically wire, and program. So you can see that they're playing a little bit down there. It's okay.
Example of troubleshooting skills.
Yes. But did you notice that the coach didn't come out of the stands and try and help the robot? They know this robot inside and out. This is their robot. They take it home and they work on it. And basically, there's no solution to this problem. This is their solution. And when they go to the competition, they're going to see 36 other solutions to the same problem. They might get an idea or something, how to make it better. And then they might change this for the next competition to make it better, to score more points, to be more competitive. The competition's broken down into 2 teams play against 2 teams. Basically, they go into a seeding match where all the teams are qualified 1 through 36. The top 8 teams advance into an elimination match where they actually pick their partners. So at any time during the qualification matches, these guys could be playing against somebody or playing with that person. So it's a very friendly environment where you never know who your partner is going to be or who you're up against. So you're always trying to share ideas, help other teams. It's a great environment to work in.
Yeah.
Yeah.
You know, one of the things I just wanted to point out is the opportunity here of failure. Without failure, there is, in my opinion, no success. So this is an event, this is a learning opportunity right here where I had one yesterday after school with a student. His robot turned it on for the first time after 3 weeks putting this thing together, burned out 2 motors. We were faced with the challenge of rebuilding his robot from scratch or starting a new one. So we debated the issue or what we should do. So we took the failure and we put it on the side, and we finally decided, let's start from scratch and let's look at this and compare that and take notes on this and see what we can do to improve from that failure.
Yeah.
So anytime we go out there and the bell rings and the robot doesn't move or there is a failure, there's a lesson there, an important lesson to be learned.
Yeah, and the whole reason why we try and have as many competitions as possible is because then they get what we call the sweaty palm theory, okay? Where they're put on the spot and they need to perform, right? But it's intense, and it gives them that desire to perform. So, Kathy, you want to show them your robot now?
Yeah. Okay, so now that we got the topic, pick up small balls and big balls. Yep. And you basically try to score them into an area.
Again, this morning.
Huh?
Just again, this works perfect.
No, it doesn't. I'm just not good at this. It's a different Alright. And it can pick up more than one after some effort.
Kathy, why don't you put them on the table?
Which table?
This one.
So this robot has an articulating claw that can raise up and down, and it can actually drop the objects. Now, the goals that they're going to put the objects in are 24 inches tall.
I got that.
Another piece of the competition is also like we're supposed to hang off the bars that's 40 inches tall. So you see we have these little hooks on the claw, and when Kathy opens the claw on the robot, then she can actually hang on the bars with ease.
Yes.
Yep.
So this behind you is the actual game, a picture of the field itself. So their objective, you want to explain the game to them?
So basically you start here and here or over there, and then you take these big balls and small balls and try to get them over here or in here. They're little things that are hard to see, but you put them in little troughs or columns, and you get more points with that. And here the bar you can hang. You also have to get under this because you can't take big balls under this. So you have to put them over and all that stuff, and you don't get points if they're on there. So
And there's a couple distinct design challenges where they have to go over a 2-inch bump in the first area and under a 12-inch bar, but then they have to score in a 24-inch goal. So there are a lot of design trade-offs. You want to come up here and show them. So this robot's designed to go under the bar, so it can lower its boom. It can pick up the big ball, and then it can raise it up in order to score in the larger goal.
wait, you move those fucking balls.
So again, as this challenge unfolds, this robot will go through many iterations during the season to get better and better. So Tom, how many robots did you build? How many versions of the robot did you build last year?
Okay,
Roughly.
I'd have to go with 8.
8. So 8 iterations of the robot. How about you, Kathy?
Like 10.
10. Okay.
I kept, like, the arm didn't work, and then the claw didn't work, and then the claw was
Right. And as they start putting these mechanical systems together, they really have a good idea. Oh well, if I did this, then this will work. But as the systems start coming together, sometimes they work better, and sometimes not so much. So, and they're constantly testing through the year. And then these competitions really allow them to test it in front of everybody and test it real. You know, because, like I said, it works great at home, right? And then you get here and it doesn't work.
Yeah, that happens everywhere.
Yeah.
No matter where you go, it's like perfect, perfect. You test it 10 times, it's perfect. You go, it fails, you're done.
So Kathy, what was wrong with it this time?
The wires popped out. We
Gotcha.
like just neated up the wires, and then some of them popped out because the tape we used wasn't tapey. Or
That's
sticky.
strong enough,
Yeah.
yes.
Do you have to run, is it just driver controlled, or is there an autonomous mode to the game?
Okay, there's a pre-autonomous, autonomous, then driver control period. The pre-autonomous just quickly runs to like reset all of the gyros on it and everything.
Well,
and
you
sensors.
have a 15-second autonomous mode where they have to do stuff and score. And if you score more points than the other team, then you get the autonomous points, which
It's
can be
10
very
points.
10 points, which
Yeah.
can be very important sometimes because sometimes it's like a tiebreaker.
And are you,
Person gets
are
the
you
autonomous.
set up to do that today, or you don't have it programmed for autonomous?
Do you have autonomouses in there right now? Oh, you don't have a switch.
Yeah, we don't have a switch here.
Okay.
Okay.
Dan, could you explain the skills of the autonomous?
Oh, sure. So there are a couple. So this is one thing that they do. They're playing a head-on match, 2 teams against 2 teams, 15-second autonomous, followed by a minute 45 operator control. At the end of the match, they have these 2 bars where they can hang. Now, another way that the students can test their skills is in 2 separate standalone competitions that we have called the driver skills and the programming skills. And during those 2 competitions, each time they're put on the field all by themselves with 60 seconds to score as many points as you can. Okay? And so the field will be set up exactly the same way, and they'll start the match and they'll just try to keep scoring as many points in driver control, and then they do the whole thing again in programming. The neat part about this aspect of the program is we have our robot events site tracks all of the competitions in the world. So we actually have a world ranking for all of the skill scores automatically in our system. And then what we also have is this year we have a state championship model where the teams have to qualify from local tournaments into a state championship, into the world championship. One of the ways that you can get into those 2 championships is through these skills only challenges. So if you do say your robot breaks in the competition, you lose, your season's not done. So if you had a really good run and you have a really good robot and something bad happened, as long as your skill score is at the top of the ranks, you could possibly still get into the world championship. So it's another way for them to really show off their skills. And at the event, we actually have another field that we run we run skills challenges while the rest of the competition's going on.
Yeah.
Do you get the balls that you actually have in the competition when you're building your robot, or
Yeah.
because you would imagine that the weight and the size would make a difference?
Yes. So one of the cool parts, we work with MWVEC Robotics for a lot of the stuff, and they do an amazing job going and sourcing all of these objects. So all the objects are 100% the same. They're all bought from the same location, and we actually supply all of our event partners with kits for the whole field, as well as little small kits that the teams can buy that have just a couple objects so they can test their designs. I just wanted to point out that on November 23rd and January 11th, there'll be 2 robotics competitions at Kennett High School. So people from all over New England will be coming into the area on those 2 dates for competitions. So if you're interested, at least go check it out. The kids have a great time. Again, it's robots, so who doesn't like that? It's a great fun, and you can actually see these robots in action. By November, I'm sure this robot will look a little different, and it'll probably be even better.
I remember last year, this is really special to a lot of people because someone from California came all the way down to New Hampshire just to try to get into the Worlds because it was the last competition of the year, and like they were so determined and came down. I wish they won, but they were close. They were close, but yeah.
Dan, I just want to point out, if you're interested in getting involved and being part and helping with the competition, contact Dan McLeon at the Kennett High School because he is absolutely looking for volunteers, and we could welcome and enjoy everyone's help.
We meet every week during the year, and that's Wednesday after school and Thursday after school at Kennett High School.
If you are interested in starting a team, I'm one of the guys that you will contact. So you can go onto the website, our RECF website. All of my contact information is there, and then you can get in touch with me. Good question.
Yeah, I'm Laura Devine. I'm the director of the Career Tech Center at the high school. And for the at-home audience, I would urge them just to come by on the 23rd or the 11th, even just as an audience member to see what's going on. It's fascinating. This is your second year in the Career Tech Center. It was a natural fit for Dan's program to move under us. So we're thrilled to have them. I'm so proud of what the kids have done. And, you know, Dan has a real passion for this, and the amount of time that he puts in, and many of our community members, you know, we couldn't do it without the community also behind us. So, you know, very thankful for that. I do have a question on, you talked about both skills and TSA, which we have been looking at. Part of our career tech requirements and Perkins funding is the CTSOs, career tech student organizations. And Dan and I talked a little bit about both skills and TSA. Now it might be a little slighted because you're on the Skills USA board, but do you, in New Hampshire, what would you recommend if they wanted to compete?
Both are waking up in New Hampshire. Not either one is very prevalent right now.
Okay.
They're both, the Skills USA, both competitions are only like 3 years old. And they have little pockets of where they're more popular. I know that there's typically a Skills USA competition in New Hampshire. And what's nice about that is if there's only a couple teams in New Hampshire, you can still participate. TSA tends to require a bigger pool of teams on how their competitions run, but their competition has a different set of rules playing the same game. So I would look into both organizations, and I can get you some more information after if you'd like. But both are great. It really depends on what you're trying to do. Question?
Yeah, I'm interested in hearing more about how the students are recruited. Who chooses to get involved with robots?
Well, from my point of view, it's an all-inclusive opportunity. It's not an obligation. And many students will tell me, well, they have this sport activity or some other sport activity, but they still want to participate in robotics after school, or the competitions are very popular as well. Well, we want to include them as well. So if you show up, then you're going to be included in one way or another. But there is no requirement. The toughest part for us is funding. And thankfully, we have a strong community that's been able to provide some funding. And as the year goes on, that becomes more and more important. But other than that, you walk in the door and you're a team member.
We also offer intro robotics classes at the high school for grades 9 and 10.
Okay.
And in the summer, we ran the summer 2 weeks of robotics camp for students entering grades 7, 8, and 9. So trying
So
to
is
capture
that
that middle school.
Proving to be a feeder system then?
Yes, I also have programming as a curriculum, which includes robotics, programming 1 and programming 2. The programming 2 is a dual credit, so you get college credits for that if you take programming 2. And that's also I think of robotics more as and effective programming. So this is what we're doing is programming. So without programming, we have a bunch of pieces of metal, basically, and electronic circuit boards. So the programming is the heart and the soul of it. Without Kathy's programming ability and Tom's programming ability, what you saw today would be impossible, even on that small scale.
I also want to point out we've been working with middle schools. So the feeder, it's just not the high school, but we're working with local middle schools to get kids there involved in the robotics program so they can feed in. As they graduate in the middle school, they're now more prepared coming into the high school, and they're learning the same marketable skill. You know, this programming language that they're writing in is a skill, it's written in C. C is a core language to everything that's out there today. So they're learning marketable skills as they're also learning how to play with robots and do some fun things.
Yeah, if there's anyone interested in starting a program at their school or any club, boys club or Girl Scouts or anything, I'd be more than glad to help get them started or give them some information on how to do that.
And anyone can join. It's like, if you have no experience or you have a lot of experience, you're allowed to walk in and go, I have no idea what we're doing. We'll show you. And we'll like help you out and show you what we're doing and all that stuff. So
That's our goal.
anybody can join. It's very welcome. It's not like, oh, you don't have a background. No, it's not like that at all. But
And, you know, that's one of the reasons why we have a year-round program. Okay, I'm also, I start all this as being a mentor, and you know the teams that I help, we have kids that play football. Well, they're gone for 2 months, and most other programs that would not let them do robots. In our program, they just come back. When they're done football, they just come back and start building robots. I get kids that've been building robots all summer long. I'm sure Kathy was Kathy was one of them. But I mean, this is the beauty of the program. It's really a training tool, and you're constantly building skills. The best part about it, from mentorship on if I look at it from a mentor, is I'm not doing all the heavy lifting anymore. Okay, what I'm really doing is I'm pushing it back onto the kids, and I'm actually being a better mentor because then I'm answering the questions that they're asking, and not trying to push them into a direction. And this also allows the teams. So I work with Trinity High School in Manchester, New Hampshire. Trinity High School now has 12 VEX teams. Of those 12 VEX teams, there's like 2 to 3 kids per team. Some kids spend 2 hours a week. Some kids spend 30. You know what I mean? It's one of the neat parts. You get what you put into it. So if these guys don't have the time to do it, okay, great. You know, maybe later on when you're done football, you can come back and do this. Oh, you play hockey? Oh, well, you're going to miss that part of it. But all the work you did over the summer, you can still go to the competitions and compete. None of that goes away. So, you know, I mean, it's a very flexible program that you can fit into a lot of different niches. But again, all about STEM education, tricking them into learning. I know we had a question about first teams. I used to be first mentor for FRC. What I did, how I got started in VEX was we were designing a curriculum for teaching robotics in schools. And basically, VEX came along. So I started 8 years ago doing VEX to teach my first team, my FRC team, how to do robotics before the January 1st kickoff. Okay? There's a lot of FRC teams that also do VEX as a training program to get those freshman and sophomore kids up and running by the time January 1st comes around. You know, FIRST is a great program, and it requires a lot of resources and a lot of great engineers, and they're doing some amazing things. And I think that VEX can really help them. There was one example in Manchester West High School, Team 501. Last year they decided to try VEX. They've been first team since its inception. What they found was they were reaching kids that they would have never reached earlier because it was at a level that they could touch. Most kids get into the robots and they go into an FRC team and they just see this big robot and only certain kids can touch it, and it's hard to get to that point. This West team was able to find kids or find talents in kids that they didn't know existed. So, oh wow, that kid likes programming. Oh, that kid's a really good builder. Oh, that student's a real good driver. Again, there's only one big robot on those teams. These little robots really allow them to express themselves and kind of show, kind of tinker as like what they like to do. So a lot of people ask me questions about, FIRST versus VEX. They're both great programs, and I would suggest to do both. Any questions? Other questions?
That's my cue. So we have a small token of our appreciation
thank
for
you.
your presentation.
No problem.
Thank you very much.
All right.
And I'm sure you can be in touch with Dan. He responds very quickly if you email him.
That's right.
So oftentimes we don't have our questions until a day or two later because that's the way the human brain works. And I would encourage you to be in touch with him. Next month our program is going to be on OSHA. It's one of those topics that everybody is gleeful to hear about. So I look forward to seeing you then.
Thank you.
Yep.
prior to a draft being put together, you wouldn't have so many issues coming forward today. People would have felt that they had an opportunity to provide input. So that's just my suggestion. We are embarking on a very exciting regional collaboration between being facilitated, I should say, by the Chamber of Commerce, Mount Washington Valley Chamber of Commerce, the Mount Washington Valley Economic Council, and my organization for which I provide directorship, the Mount Washington Valley Housing Coalition. It's a great place to have full discussions about this type of issue. And in lieu of changing the GASIT process, I would ask that you ask for our input prior to creating the initial draft so that we feel heard prior to that. Thank you very much.
Thank you.
Thank you, Teresa. Bill, would you make sure that that suggestion is taken up the next time you have all of the regional planning commissioners, directors in?
Yes, yeah, no, absolutely. A question I've made Teresa get in touch with you after just to find out, 'cause we are always looking to improve the process. I mean, this time we did do a lot more communication in the past, ahead of time with the regional planning commissions and some of the feedback and their technical advisory committees. But yeah, there's always room for improvement. So I'd like to talk to you. Thank you.
And I just want to add to all of our TAC meetings are open to the public, and we can make more of an effort to, when we're presenting our prioritized lists to the TAC to approve, we can make more of an effort to let all of our communities know about that. So you could, even if you don't necessarily have a vote on the TAC, you could still come out in support of certain projects, and we can make sure that the TAC hears your voice, and so that might help as well.
Okay, anyone else?
Quickly, I would just like to remind us, because I was also selected in 1980 when I started working on this, so that things don't get lost in memory as time goes on. I just remind us that the EPA gave a permit for the bypass conditional upon us doing the north-south road and everything else we could possibly do to avoid doing the bypass. So it's fine you laid it out. I think the corridor probably should be preserved.